And we're back. So, welcome back to the stream. It is Friday, and I'm kind of tired, and it's been a long day. So I'm gonna only stream for an hour, unfortunately, or fortunately, depending on how you look towards things. But yeah, we're gonna try to finish up the design selection for the shooting mechanism today. Hopefully, get through all of it. As for a quick recap for last time. What we essentially did, we were overlooking. Let me see if I could change this for you guys. Yeah, that's better. Okay. We were overlooking all the different shooting mechanism designs and trying to rate each one, and then hopefully after we rate all the options, we choose one, and then that'll be our selection or design that we're gonna stick with for throughout the whole project. So. Yesterday, we finished analyzing the shooting mechanism for the tennis ball shooter. Essentially, you have two wheels connected to motors. Those are rotating, and then you put the ball in between, and it will launch the ball on some sort of a pipe. We're gonna make this a tube, so that we have more control over the ball's position and where it's going to be shot. So that's where we left off yesterday. We gave it a 7 out of 10. It's a decent design. There are... Oh, hey Dane, how's it going? I know you were trying to catch these streams, so glad you could catch one live. So yeah. So yesterday, let me see if I still have it. I don't know if I saved my notes from yesterday. But yeah, so we gave that a 7. We also started looking over the spring-loaded shooter. There was actually a critical issue with this design, because although we could use like a spring-loaded system, we could decompress the spring by wrapping this rope around a pulley and pull the spring back to decompress it, and then let it go to launch the ball. I'm doing great, Dane. Nothing much. Just got home from work. Kind of long day, but now we're streaming, so more of the fun stuff tonight. Yeah, so. But yeah, there's a fatal flaw with this spring-loaded design, is that if we let this latch go, it would there's nothing to put the latch back onto the pin or whatever's we're pulling back. So there's a big issue with that, which I overlooked completely. There may be ways to combat that. As far as I know, I can't really think of one. So that's a big flaw, and that makes this design a lot more complicated, because now we need some sort of mechanism to make this reload, so to speak. So there's an issue there, and I really don't want to deal with that issue. Besides that, I don't know what other potential flaw can happen. Again, we're probably going to use a tube for this section, so we have more control over the ball. Besides that, I don't know if there's any cons or even pros to this design. The pro is like it's actually more complicated than it has to be, in my opinion. I believe the tennis ball shooter is a lot easier in design, because you don't have all these different types of mechanisms. This is just a wheel and a motor, essentially just a motor. But here we got a whole pulley system, essentially, with the spring, and then we have to reload it somehow. So I guess, relatively speaking, what I could do is, if I gave this a 7 out of 10 last time, this has to be below 7 out of 10, simply because of that reloading factor. Unless we could come up with a clever way to combat that. I don't know of any yet. I was trying to think about this throughout the day, and I can't think of one. So, is that. I did mention yesterday that we had like some sort of rail right here, and then maybe like some sort of notch or something that could retract, go up and down, so that we could just pull this forward and pull it back and reload it that way. But that requires like another motor or some sort of gear system, so we could transfer that power from the motor to not only that. Oh well, no, we only need one motor. Never mind. Because at that point we wouldn't even need the pulley system. We'll just need something like this. So yeah, we could just use that to be honest. So we could change the design a little bit to be, I don't know, maybe have like a belt or something, and then on this belt we have that little latch, and then it's guided somehow. So the belt goes like that. This goes to the motor, and then there'll be like a pulley over there or something. And then basically we rotate this. This causes it to move back to move the spring, to decompress the spring. And then basically, oh well, we'll need something to make this go down. So there's that as well. Yeah, I feel like this is just too complicated. I'm also like not thinking as much as I was previously. So I'm just gonna leave it at that. Like a 3, I would say, because it's just unnecessarily complicated, I think. I'll give it a 3 or 4. I'll give it a 4. A 4. So I'll just put it right here. It's gonna look ugly. So feel free to chime in if you have any ideas. I'm not discriminating against any ideas. As long as it's a legitimate idea, something like ridiculous, but I like to have fun, so I wouldn't mind any idea. So 4 out of 10. Spring-loaded shooter. Cool in concept. I was actually hoping for this to be a great concept, but I forgot about how to reload it. I mean, we can do it manually, but that kind of defeats the whole purpose of it being like a robot, so to speak. So, oh well. Another design we thought of is the fan shooter. Really simple, to be honest. I mean, one issue is like how we're gonna load it. Like if we load, like let's say we have that gravity fed reservoir, we'll need to put okay, this thing is simple. Let's just put that. It's very simple. It's just a fan and a tube, and that's pretty much it. You turn on the fan, it moves the ball. That's it. I already see a few issues with that. An issue being like the fan will once the fan starts turning significantly, a minimum threshold for the ping pong ball. I would try making a suggestion, but I'm not very good at this stuff. I just find it interesting. Hey, it's fine. No, it's cool. Like I'm not expecting. If you want to participate, it's up to you. But yeah. I mean, I don't have the greatest ideas, but I'll try my best. I'm just thinking out loud, really, as we go through this process and hopefully get something going. So, but I really hope this will work. I mean, I have no expectation of it working, but it'll be fun to make. I think the process I'll definitely learn a lot. You guys may learn a lot, so there's that. So, with this one, the only problem that I see is that if we turn on the fan very slightly, the ball will start moving. You know, when I say slightly, like the ball has a minimal threshold, like its weight, its normal force or whatever is only thing preventing it from moving forward, because there's nothing stopping the ball in front of it. So once the fan is spinning fast enough and producing a thrust for the sorry about that. That's a problem. Oh no. Hold on. I'll be right back. Sorry about that. I can't play music. Sorry. Oh god. I didn't turn off the mic, which is great. Alright, cool. Okay, we should be good now. Okay, anyway, back to what I was saying. If the fan is moving at a speed that provides enough air to move the ball, then we don't have control over how fast or how far the ball can be thrown or be projectile. Simply because it'll just start moving on its own. So although this design is simple, it's going to be more complicated because we need to have the input to the fan to be variable. Meaning that we need the speed of the fan to be at different speeds so we could vary the distance thrown, basically. So that is an issue. We can put, again, another type of latch in front of it and somehow retract it, so like have it swing up, and then we could launch the ball once the fan reaches that certain speed. We could do something like that. Again, that's still complicated because then we need another like motor here to rotate it, right? Or the other direction, but I don't know. What I could do, what if I the fan goes that way. Maybe, yeah, I mean, like, I don't see, this is like the difficult part when it comes to like designing and concept generation. Like, although it seems like a good idea at first, but once you start really looking at the details of it, how it really functions, you start seeing the flaws like immediately. So like it seems like the problem here is how to keep the ball from moving, or how it enters the location to move the ball, if that makes sense. To be honest, it's not really different from any other design. That, like, it shouldn't matter because all these designs have that issue. I mean, I guess what we could do instead of I guess what we could do, if we use that gravity fed reservoir that we came up with earlier, this one, if we use that, we would just have to control when the ball would come out, and when the ball comes out is when the fan reaches that certain speed, so we get that precise distance to be thrown. But then again, we still need some sort of latch mechanism. It seems like that's a common issue when you need some sort of mechanism that controls that only one ball is sent at a time, at the right time too. Okay, so this seems like the same issue as the spring-loaded option. Okay, given that, simply because I think less parts are going to go into the fan shooter, it's a better design because it has less parts relative to the spring-loaded system. Because the spring-loaded system, it requires like a motor, string, pulley, and then some sort of latch system and a spring. All this is just a fan and a tube. So relatively speaking, this is higher than the spring-loaded system, but lower than the tennis ball shooter. So I guess in between, like 5.5. Yeah, I'll give it a 5.5. So, I mean, that's how I'm thinking about it. I just try to put it in relative terms because it only makes sense that way. Yeah. Alright, sweet. So, I mean, we're kind of go through this pretty quickly, but I kind of want to move on from the theory and start doing some 3D modeling. That's like my favorite part. I don't know, I just like to make highly detailed 3D models for some reason. It's like, I don't know, like drafting or making drawings or doing any kind of technical drawing. I find that like not satisfying, but like it calms your nerves. Like it's just like you lose the space. You're just doing, I don't know. It's weird. It's like a zen almost. It sounds weird, but I don't know. Okay, like a catapult. Okay, so we have 7 out of 10, 4 out of 10, 5.5 to meet in the middle. The catapult design. The biggest issue I see immediately, I mean, all I see is issues, right? I haven't even talked about pros yet, but the biggest issue, if you want a retractable arm for this, I don't know how we're going to design that. Like, I can't think of a way how, unless we layer like conveyor belts on top of each other, if you know what I mean. Like if we did, oh well, not conveyor belts because they don't retract. Like what I'm saying, we need the whole system to be like this initially. Like they're like coupled, right? And then here's the little spoon that holds the ball. And then later, it needs to be like fully retracted or expanded, if that's the right term. Like, I don't know how to do that per se, but my off screen. But that's one design. I don't like how do you say it? Oh, sorry, I didn't see your message. Would a button that gets pressed when the ball rolls past work for the lat hatch? Are you saying like once the ball rolls and then like hits a button or a switch? Are you saying something like that? Because that could work. I didn't think about that. Let me see. So yeah, or maybe we can do that. So let me see how it would work in this scenario. Okay, let me see. So if it also comes down to thinking how the balls are going to be loaded into the system. We came up with 2 different ways, being the reservoir, like the gravity fed reservoir, as well as the spring-loaded, like, clip, almost. So, for the gravity-fed reservoir, we could use some sort of button switch to do that, because, like, we don't have any other way to signify a ball has, been loaded in the system. So, trying really hard to do this. So if we put a button here, let's just do hypotheticals, right? Let's say like there's I didn't change color. Let's say there's a big button here, and then the ball lands on top of it. They'll detect the ball being there, Hmm. I don't think the okay, because the button's supposed to signify if the ball's loaded. We could use that for like a sensing system, but it doesn't actually prevent the ball from moving, right? Unless I'm thinking about this wrong. Yeah. The only problem is if the ball is too light, then it might not be. That's also true. Yeah, we do need a very sensitive switch. And if we do have a very sensitive switch, depending on the mechanism we choose, the fan can actually activate the button. Um, so that can be an issue. Yeah, I mean, it's really hard to. I mean, there should be. Because, like, I'm thinking of an actual, like, maybe like an airsoft gun or something. Like, what is their mechanism that prevents, like, the BBs from spilling out of the barrel or something, right? It's basically the same problem we're having here. I think it would be better with a small button. Yeah, I mean, if we could find a small button that is sensitive enough to detect a ping pong ball, then yeah, we could definitely use that. I think we're gonna do some research because, like, I mean, Google's our friend. I mean, I'm just kind of curious of how, like, I guess airsoft guns work. I don't really know what kind of mechanism goes behind that. So let me just check that out. Let me see. Or if you know of any other system that works similarly, maybe we could look at it, learn how it works, and then maybe use the design. Um, to be honest, that's how most things are done nowadays. You find a similar design. I mean, that's kind of you find something that works very similarly, and then you take that and then adapt it to your system. That's a lot. That's a lot of things that people do. Um, like let's see. I'm trying to make this work. Here we go. Okay. How does spring? Oh no. How does airsoft gun work? Is it spring loaded? Okay. How do airsoft guns work? This is a video. Trump. Take the survey. No, thank you. Maybe something that doesn't need to be pressed but detects when the ball goes past. Yeah, we could do. We do like I think I mentioned the. Here, let me bring this back up. So we were going over the different types of sensors we could have previously. So what I came up with and a few others in the chat came up with is some sort of RF sensors. So one of the people in the chat said you could put like an RF sensor. It's like a radio frequency signal. It's a little chip that's like really light. It's super light, so you could like cut open the ping pong ball and like make a little slit and just toss that thing in there, and then somehow control it with another RF transmitter, and then you could sense if the ball has gone somewhere. So it's like so you could determine the ball's location essentially. So which could be useful. So there's that. We also thought of the ultrasonic sensor. If you're unfamiliar with that, it's essentially a. Let me pull up a picture. I think it's better to see a picture of an ultrasonic sensor. Fat. Yeah, it's like one of these. These are very typical. You would see these a lot. Basically, those two. Can I just do this? These two circles emit radio frequencies, I think, or ultrasonic sound at a certain frequency or wavelength, and then it'll basically hit or ping something, an object that's within range, and then come back to the sensor on the board. So essentially, it takes that time traveled or the time to emit and then hit the object and then come back, it takes that time, and using the frequency or the wavelength of the radio signal, it does the math and figure out, okay, this is how far an object is. So we could just basically use that to sense if the ball has passed through the tube. If the sensor will say like, oh, there's something here, ball has been passed or something. It's something like that. We also thought of like a color sensor. This will be more than likely using like a Raspberry Pi or something, and its camera. And essentially, you have like this little algorithm. They have a module called or a programming library, in other words, called OpenCV, and they could do color detection. So if we choose a ping pong ball to be bright orange or even white, as long as the background or the environment doesn't have anything white in it, we could use that to detect the color of the ball. This only works when there's a stark contrast in color, obviously. Or it works best in that scenario, I should say. You could do some filtering with it. There's this thing called the Hough Transform. You could basically... This is actually some cool stuff, because this is what I did for my senior design project. I could probably show you guys if you guys are interested. But let me show you just quickly what a Hough Transform is. It's kind of unrelated, but it's pretty cool. This is how like people basically filter out images. Like this is how you can think of like Tesla, how they detect basically lines on the road for their AI driving system. So like here, you could see like, so there's multiple steps to filtering out an image, but essentially you could have, let me see if they have like an example of transform filter. Here we go. This is good. So you start off with, let me see if I could open a new image. So you start off with A, right? That's your raw image. Usually it's in color. And then usually a typical step when you do some analyzing with the image, you change it to black and white. Simply because you get rid of all the noisiness of color. So now you're only working in a hue of 0 to 250 or 255 bits, if that makes so. 0 would be, I believe, white, and then 255 would be black. And all those numbers in between give you the gradient of like white, gray to black. And that's a lot easier to work with than with color. So with color, you have all that. You have 0 to 255 for the hue of the gray and blackness of the image, but you also have red, green, and blue. So you stack on more layers of color, which is unnecessary to analyze an image. So the first step, you get a raw image in color. Second step, black and white. Third step, you do this thing called the Hough Transform, and what it does is basically detect edges of objects. Again, it depends on the image that you take, but if you have a very contrasting image, you can detect lines in step B. And then you can do further processing. You can do what, because you'll retrieve a lot of data, essentially, and you can use that to basically create an artificial intelligence. Not I don't think it's really an AI, but you could use what you know about the image and then tell the program to do something about it. And essentially they did, I don't know what this would be, but they filtered out even more to get something more useful. And then in product, they detected the pupil of the eye. It's step of process. This is image processing. I use the same. I try to use the same concept in my senior design project. It didn't end up so well. It was great in theory, like how we're doing now with the ping pong ball shooter. It's great in theory, but in practice, it was beyond my scope of knowledge, and we didn't have enough time. So timing is an issue. Got to get the product out. So you can't. It's hard when you're working with things and when you have timelines and budgets and stuff like that. So although it was a cool project, I didn't get it. I wish I could show you guys. I mean, if you guys are interested to see the stuff, I do have a folder potentially. I do have a folder if you guys want to see it. Just let me know of how. I think I have a little short presentation. But this is pretty cool. Like, you may think this is unrelated to the Hough Transform, but it actually is. Essentially, what you did, what this shows you is basically the transformation of an image, and it compiles it into this domain, or how do you say this transform. That's essentially what a transform is. You go from like XY plane to like r and theta, like polar coordinates, to rectangular coordinates. That's called the transformation, if you guys are following there. But essentially that sort of transformation is the same thing you see here. And what's important about this graph is that where there's high density of like whiteness, that means there is an edge there. So you could say like, oh, this is an edge, this point is an edge, this is an edge, or this is an edge. And then you take that information and then you put it into like this image. And then you get your outline. So you kind of be, yeah. So if you guys think this is like weird or artistic, it's really an output of the Hough Transform. So that was a complete sidetrack. I was just letting you guys know. But yeah, you can see like this is how would Tesla detect like the roads or the lines on a road or something. So, or this may be a better picture, but I'm pretty sure the algorithm is way more complicated than that. I'm pretty sure you got probably hundreds of engineers working on that, and just the fact of that's mind-boggling. Like I don't know how in depth the software would go. But it'd be interesting to know, but it's going to be a very steep learning curve. Yeah. So, anyway. Besides that was a long tangent on the Hough Transform. We were talking about sensors. So, yeah, we were talking about a color sensor to detect where the ball, or if the ball is there or not. Stepper motors. It's not really a sensor. It's more just like a thing that we control. So it's more of an actuator than anything. But it does sense in a way. There's some sort of feedback that controls the motor. So sensor detect how many balls are left. Very general. RFID tags. Yeah, we talked about that. So yeah, the reason why we were talking about that was because we were talking about a button to control if the ball, or to control when the ball is going to be propelled forward. I still don't know how we're going to do that, because it seems like that's a common issue. We can use a button, I just can't figure out where to put it, or like what kind of button we would use. I mean, we could wrap aluminum foil around this thing and just have like little aluminum foil like tags everywhere, like what we came up with the, how do you say it, with the spring loaded thing right here. So essentially we just put, a piece of aluminum here on the ground of this spring loaded thing, and then basically as one ball goes out of this cartridge, it'll get closer to this other contact, and essentially when there's 0 balls in the cartridge, these will make a connection, basically creating a short, giving us a switch or a signal, so we could use that to detect how many balls are left. But we could maybe use that so we could detect when a ball is going to be shot, or before it is like going to be shot. So yeah, it seems like the issue here is like we need some sort of like a latch or door or something to prevent the ball from going. Like it has to reload somehow. I feel like that's a common issue. Even this design, even though it's a simpler and easier design, it still has that issue of having only one ball to come out at a time. You don't want all of them to come out. There's no point of that. I think this would be simple if... well, I don't know. Yeah, I haven't really thought about, because it seems like the main issue now, we look at the larger scope of things, like across all this concepts that we have here. I think the main issue is that these two, the shooting mechanism and the, how do you say it, how we store the ping pong balls, how we're gonna have that basically reloading capacity or capability, how those two systems are gonna connect. I feel like that is a common issue that we're gonna have between these designs. It seems like we're gonna have that issue. And for those who are watching, I'm just letting you guys know I'm only gonna stream for an hour today. It's just it's Friday. Kind of tired. Kind of done with work for the week, so I'm just like, okay. But starting next week, I'm gonna stream only 3 days a week. I want to do Monday, Tuesday, Wednesday, and then leave Thursday and Friday free, simply because I want to do also YouTube things like regular YouTube content videos. I have a few in mind that I want to make, so yeah, I don't want to put my whole channel in just streaming. I still want to make just regular content for YouTube, so I'm just letting you guys know. And I did start at 6:30 roughly, so 7:30 is when I'm gonna end, or in like 30 minutes or so. But just letting you guys know, keep you guys updated. But yeah. So maybe we shouldn't worry about this reloading aspect yet, because it's not part of the mechanism. Except for this one, we do need to reload the spring. That's not reloading the ball, that's reloading the spring. I guess that's the same issue here. Okay, so we'll keep that in mind for now. Basically, we have this catapult right here. That's what we're looking at. Yeah. So what I was talking about earlier, I'm kind of losing my train of thought. I'm kind of getting sidetracked. So we're talking about catapult. The issue here is having the arm being retractable. What makes that difficult is like I have no idea how to make it retractable. I'm thinking it's something like how fire trucks do it. You know, they're ladders that go out. How that works, we could probably take that design. How do fire truck ladders work? So something like this. Like how do they do it? I don't want that. Maybe we could just watch one. Do you guys hear this? I don't know if I should play audio, to be honest. I don't want to like... Okay, this is actually a good view. So let's see how this thing works. Maybe we could dissect this thing. So it looks like they stack them. Okay, let me make this bigger. Looks like they stack them on top of each other. And they also cascade, but they cascade like... It's like one of those dolls that, like, there's a doll inside of a doll inside of another doll. It looks like that, so let's keep that in mind. Let's see. It's not moving. Oh, there we go. Okay. So it looks like they're using rails on the side. They're probably using some sort of, like... ratcheting system almost, like they have like a I don't know, actually. I really don't know. Like I could see like this working with multiple motors, but I don't want like all these motors all over the place. Ideally I just want one or two, like that's it. But like I don't know how they slide this up and down. Yeah, I'm not sure how you would do that. It's always the simple things that I get stuck on. Like it should be fairly simple to understand, but I don't see it. Maybe there's a diagram or something. I'm thinking, the toy truck will show it. I don't think so. It's more of a crane. Yeah, I'm not sure really. It looks like they use some sort of rail. I'm also thinking maybe the system looks like this. Like maybe you could have basically you have that same system where they're cascading on each other. There's one inside and there's another, and then you basically just push them. Oh, I guess you could use stepper motors, huh? To do that, to control the location, because stepper motors could hold their position. So maybe you could put a motor there on some sort of like belt or something, and it'll caught or in a gear, and then have it rotate, and then somehow the thing that rotates is connected to the thing that wants to expand. I don't know. Yeah, this is just another complicated design. You know, good in concept, but in execution, maybe not the best. If you guys want to talk about some physics, there's a thing. If we're gonna choose this design, the catapult, we have to be completely aware of how do you say it? Yeah, Dan, I think it's a rail too. To be honest, uh, yeah, I just don't know how they cascade it though. Like I'm thinking there's a motor somewhere, right? And then somehow that motor is connected on a belt or a chain or something, right? And then somehow that belt is connected to the actual platform that's moving forward. I just don't know how they attach the belt to the the actual system. Like what I'm also thinking of, what also comes to mind is how escalators work. I think they have a very similar system, like something like this, right? Basically, they just said, like, yeah, this is probably what we're looking for. Um, can I get an image, please? Um, like how this, see, they're using like a gear to hold its position. I think it's more like this than anything, and they basically have a series of these for each one that goes out. I think that's how they do it. um Maybe. Yeah, feel free to do research again. If you guys have any ideas or any concepts, feel free to shout them out. Like I'm definitely open for all kinds of ideas, because that's usually how. I mean, I've been in industry for a year, and it seems like when I'm talking to engineers, senior engineers, even upper management, when coming up or brainstorming ideas, everyone has their input, and just, you know, no one's an idiot, so to speak. Like everyone, even if your idea is not the best, they'll think it out. They'll like, okay, is this actually a solution or not? And they'll tell you. They won't just tell you like it like sucks. I mean, I won't do that. Trust me. But they'll give you reasons to maybe, oh, make this better or do this instead. You know. So it's all a learning experience. I'm not here to, you know, be pedantic or anything like that. So I'm thinking something like this. I don't know. Again, is it worth all the trouble? I still think the tennis ball shooter is so simple. Like you just put two wheels and then launch the ball. I mean, it's been done before. It's effective. I'm already leaning towards it, but I shouldn't be biased yet. We have to go through all the analysis. But but going back to the physics thing, one thing we got to worry about, if we're gonna choose this catapult design, we have to worry about, let's say, so we have the catapult. We're gonna draw it as this bar. If we change the length of this part right here, where the ball is held, this distance r, there's this thing called angular velocity. Yeah, I know. That's what I saw too. It was nothing but toys. But yeah, hey, to be honest, some toys have great physics behind them, and like if you learn how those mechanisms work, you could definitely apply them here. It's no different. You know, it's just smaller and more kid friendly, I guess. But going back to, if we choose the crane, the distance from the pivot point, which is going to be the motor, right, is going to vary. And if that varies as this ball or as the crane rotates, right, we're also going to increase the the linear velocity, not angular. Angular velocity is constant or depend on the motor. But the linear velocity, meaning let's say if we threw this ball, right, on this path or projectile, the linear velocity, which is the speed of the ball tangent to the curve, or basically, yeah, it's tangential speed, is going to increase because the angular velocity omega, it's typically known as, is equal to r times v. So you can think of it as a moment or a torque almost. Not really. It's not really a torque, but it's an angular velocity. Or the linear velocity is dependent on how far you're gonna throw or how far the crane is, right? So if you like look at my arm, I don't know, here, you could see that if this is my pivot point, right? If this is my pivot point, kind of right there, right? You could see that my fist is moving faster than my elbow. It's so simply because how long my arm is. So if I, decrease my arm's length and rotate it, my wrist, it's technically going slower at that point, at the farthest point. So we got to keep that in mind if we're going to control the power of the device. So that's one thing we have to be careful about, because now the magnitude not only increases due to the angular velocity of the motor, but also increases with the length of the catapult. And the reason why we want to make the arm longer or shorter is because we want to control the position of where the ball is going to be thrown. So there's that, or even the magnitude. So this one, simply because of those two things, we have a complex design. We have a complex design. It never changes color. I don't know why. We have a complex design, and we have to do a lot more analysis, or mathematical analysis. Oh, and another thing, if you do, yeah, feel free to research on your own. That's definitely up to you, man. I mean, I'm not forcing you. If you want to come along and design too, it's fine. Yeah, I'm ready for all answers. I'll be here Monday, Tuesday, and Wednesday, ideally. I'll let you guys know if I'm not gonna stream one day. So, but one thing we do gotta keep in mind though is the crane. That the center of mass will move if we elongate the arm or the catapult. So what I'm saying, let's say this is the base, and then we have the motor, and then the catapult mechanism. The center of mass of this thing is going to be roughly right here. So this is going to be the weight of the object. But if we make it longer, right, we're gonna move that center mass forward. So now the weight is distributed farther away from the system, which would mean that there's more tendency of the whole system to rotate. To combat that, a very simple way to combat that is to add 1,000 pounds here, right, or something very heavy so it won't rotate. Yeah, we could definitely do that. I mean, we can. Yeah, no, we could do that. Yeah, yeah. If we had, yeah, no, we could definitely use the motors to on each stage to move this forward. But you gave me an idea. What I was thinking is how we saw on the, what do you call it? On this thing, the escalator. Why can't we just put the ball on the escalator and then have it stop here? and then from there we just launch the ball. Does that make sense? Like, okay, I'm gonna move this all the way over here so we could see that. So have the mechanism, right? We'll have like a cup or some sort of thing that holds the ball, right? So this will be the ball. And then what we can do is like, you know, put this on like a little pin over here and then another pin over here, and then put this on a guide or a rail or whatever you want to call it. So like a slot, essentially. It never changes color, I don't know why. But you could put it like this, right? And this would be like on the other side. Something like this, right? And then this would be like attached to, I don't know, maybe not even that, we just use, oh, well, something, right? We use something, and then we just rotate here, put a motor here, and then maybe just across it so we don't have to have multiple motors. So this is just one motor connected together. And then this will rotate that direction, or actually in this direction. It'll rotate that direction, which will bring the ball up. Like something like that. So it's like an elevator for like a ping pong ball or something. Maybe that could be a better solution. And then we can control, and the cool thing about this is like the center of mass doesn't change. It's constant, right? It's this whole system. Like this thing's not retractable anymore. The only thing that's changed is the location of the ball. We can actually do that. That's not a bad idea. Yeah. See, your input does help. It sparks new ideas. It gives us ability to create something new. So we could probably use that instead. I mean, the mechanism's not fully thought out, but it's at least better than what we had before. Can I move this? Jesus. Can I? Nope. Oh, maybe that's why. It's not working. But yeah, I was trying to move it down here. But yeah, that's definitely a better design, in my opinion, than using this catapult system. It's a lot simpler in my eyes, and it simplifies the design tremendously. So, okay, so that's a lot better. And how we load a ping pong ball, we just have to basically make sure it just lands on this cup thing, right? We could use like a gravity fed system. So we could just connect this thing to it. The ball will just roll out of this reservoir and then go to the little cup. And then we could vary the height of the ball and then launch the ball. I do realize we need another motor. And this system requires at least 2 motors, simply because we have the ability to rotate it, or move or translate the ball up and down the rail, but we don't have the ability to rotate the whole system yet. So we would require maybe this system or this point to be rotated. So we probably have to connect this whole thing to another motor or something. So it's not as elegant, but it could work. Okay, I like that. I think that's a little bit better than the fan system. Do you think some kind of fan would work to launch the ball if it's simpler? Yeah, no, the fan is definitely the simplest option. The only problem with the fan is like we need to control when the ball gets to the fan. Because again, like if the ball is sitting in a tube, right, by itself without the fan being on, if we turn on the fan just a little bit, since the ball is really light, it can start moving. And if we're going to try to control how far the ball is launched, we want the fan to be at a certain RPM or a certain speed before the ball moves. So that way we get the desired location of the ball, or how far the ball we want. So yeah, it's definitely a simpler design. It's just because it's like less parts, just a tube and a fan, really. That's a very bare minimum of the mechanism, but we also need to control when the ball gets to the fan. That's the only problem. Again, I think we were about to do that. I was trying to look up how we were looking at this video, how airsoft guns work, because their loading mechanism is okay. So they have, I guess we're gonna watch this video together for a bit.
Piston and piston head, a cylinder.
Oh, they have a solenoid
To pull the trigger.
Okay, hold on.
And BB. This.
So it looks like they have. Yeah, I mean, they have a. You know what I realize? I mean, again, you start looking at other mechanisms, and ideas start coming, right? This is going off the topic of what we were talking about, but what I do realize, what we can be doing for this spring-loaded system is not use a spring. Why use a spring when we could use a solenoid? So if you guys don't know what solenoids are, they're basically a piston controlled by electrically. So basically you just have like a pin being launched electrically. So let me see if I could, if I'm thinking about this right. Solenoid valve? Oh, maybe it's the air. Oh, is it air? I thought it was the piston. Solenoid. Hold on, maybe I mixed up the terms. Yeah, like one of these. Oh god, it's one of those videos. But so yeah, there's a little rod and it's controlled, it's a magnetic, and then you can create a magnetic field by passing current through a coil. The coil creates the magnetic field, and basically you can control the speed of the rod by changing the current of the coil, or going through the coil. So let me show you in a legit one, like do they have like a real, yeah, like this guy has it. Sorry for the ads. I realized we could have used this the whole time. This actually makes a spring-loaded system a lot simpler. If only if the solenoid is variable, meaning we have different power settings, which I think it should. I don't see why not. So let's see.
The solenoid will continue to apply force.
So
the most common type of solenoid acts as a linear actuator that retracts when electric current is applied.
see how it's
Current
going
is
in and out?
maintained, the solenoid will continue to apply force. A solenoid only returns to its extended state if a spring or a force is applied.
So yeah, that's exactly what we need. If we could control how fast we could send that little
A
piston,
solenoid consists of an electromagnetic
then it
coil,
could be a possibility.
high permeability core like iron to direct the magnetic field.
Yeah, I mean, yeah, to be honest, fire trucks seem to be like a mysterious thing, because I really don't know how those things work. Yeah, it's they figured it out. We're just looking at it. We can't figure it out. It's funny, but yeah, but I think a solenoid might be a good option.
When current is applied to the coil, the armature is attracted.
Yeah.
There's coil
Okay, let me see if we have a variable solenoid valve. No, solenoid piston. something like this.
The Superstroke solenoid from G+. By modifying the geometry of the pole piece,
If it's that
the
slow
magnetic
though, it won't
return
be
path of
useful.
the tubular solenoid, G+ engineers have produced a device which develops useful force over
Hey man,
exceptionally
I go
large
on
strength.
Ask Reddit sometimes, and they do have
Characteristics
they
of
have some good
proportional
questions.
solenoid.
So you could even try Ask Engineers too, and they'll probably give you a really legit answer. So r/Ask Engineers, I
Because the
believe.
solenoid has been loaded with a spring that has a rising rate force characteristic. As the current increases,
Yeah. So if we could find one of these that is more faster, more powerful, then we might be able to use that. So let me see. One of my favorite, or one of the common websites that a lot of engineers use, called McMaster Card. The cool thing is that they're not limited to companies. You could be a regular person and just buy parts at low volume. So it's really cool. But also a lot of companies use this to buy parts or prototype and stuff like that. So it's highly convenient. But let me help you guys out. So it's usually under linear actuators. Let me see. Or power transmission. Let me see. Well, I could just type it, I guess. Scaled. Spend less time on the solenoid maintenance and dirty environment. Okay. Economically, and use open frame solenoids. Okay, that might be it. Compact. Then profile. That might be useful because we want the system to be light. It can't. There's no use of it being, how you say, heavy. If that makes sense. So, there's that. Rotary solenoid. Yeah. So I'm gonna high force linear solenoids. These are probably way too much for what we need. So let's see. Yeah, 120 volts AC. I mean, we can hook one up. I mean, we could hook one up to the wall, but we probably need some sort of voltage regulator. My bad. So we can get that. I think in the US we have 240. Hold on. US wall outlet voltage. It's 120. Oh, okay, perfect. So we could just, I don't know how safe that is, just using it's probably not safe at all, what I'm thinking. Where'd it go? Yeah, so we could take one of these. But we have to control it as well. So we need some sort of controller. Do we have just like a DC one? 12 volt DC, here we go. Pull half. Maximum stroke length. 1 inch. How much are these things? $35? This is not bad. For a solenoid, it's not bad. Huh. I mean, again, we're just concept designing. So, price doesn't matter for now. For DC voltage, pull push. We just want push, right? So if we take this thing, if we look at this, is it variable though? Oh, force at 10% stroke length, 45 ounces. 45 ounces. Wait, what? That doesn't make sense. Wait, I'm not reading this correctly. I'm sorry if the... how do I make this so you guys can see it? So, 45 ounces. That doesn't make sense though. 45 ounces, how's that? At 10% stroke length, it's 45 ounces. Why does it decrease as I increase the stroke length? I'm not sure. But it looks like we could vary it because it's telling us percentages. Yeah, they do use hydraulics. Oh, well, yeah, they do, huh? It's probably underneath the crane. Huh. Maybe we could use something like that. Yeah. I mean, I'm not sure. Because hydraulics are usually pretty loud. I'm not loud. Pretty big, and pretty powerful. So it might be overkill unless we find a very small like hydraulic piston, which is kind of like a solenoid. I don't know, but we could look into that too. Maybe we could check it out now. To be honest, hydraulic cylinders. Let's try that one. I think, wait, actually these might be better for, if this works how I think it works. We want one of these, the compact ones. Oh Jesus, 12. Yeah, no, this is definitely overkill. If we send 1,200 pounds of force, that ball will be like shredded. It will reach terminal velocity before we exit the tube. Like, that is extremely overkill. And these are compact. That's pretty powerful. If the stroke is 1 inch, and we could get 1,200 pounds, this thing could like kill someone. Like, let's put that in perspective. I don't know. I like to do that when I don't fully get measurements. Like 1,200 pounds. It's like, how much is that? How much? Yeah, I know that, but like, do we have like a perspective scale? Well, it's a ton, right? So technically, it's like a cow or like a horse, or is a horse 2 tons? No, a horse can't be 2 tons. A horse is like a ton. So it's like a horse, like running into a horse at full speed. Like, that is extremely overkill. That's true. I forgot about that. We can use. I mean, I'm not against that at all. We could buy used parts. We don't have to reinvent the wheel. So yeah, we could definitely look at robotic arms. I mean, we should have done that in the first place, to be honest, because, again, don't need to reinvent the wheel. I mean, it is fun because you'll learn a lot, but it is highly unnecessary. So I'm gonna assume like Arduino or something. To be honest, we could just buy. I mean, if you want to end the project now, we could just buy one of these and then just control it. You know, because then all we have to do is control the arm, and then we're pretty much done. Maybe add a camera. I mean, we could take the design though. Yeah. But we could definitely take the design. Oh God. Oh. I mean, this guy did it out of like cardboard or something. Toothpicks. I use servo motors.
Hello, hackers.
Hack
In
to.
today's video, I will show you how you can make earth motors and wooden patch the show.
I wish my videos looked this nice. But then again, I don't really make the. I usually just make shit posts.
We are using 420. The control board is almost finished and look good.
Yeah, so.
Next step is wiring and extend the wires from servos.
Yeah, we could look into how these things work. I mean, it's really, these are like robotic, or like links. They're called links. Essentially, there's this thing called, there's a larger bottom for whatever makes it move up and down. Are you talking about like one we saw, or you saw one that has one? On the orange one. This one? It looks like it pivots around this little circle. Oh, you mean like the bottom platform? Like this rotates around here? Yeah. Yeah, we were talking about that. Essentially, we're gonna need a way to, since this robot's gonna be stationary, we plan, or at least I plan on using this mechanism. So since the whole object is stationary, it's not translating. All it is rotating a given on some axes. So so if this is the robot or whatever, it's gonna have a platform to rotate in this direction and then in this direction. So that way you have, I guess, 2 degrees of freedom to rotate somewhere, and that should give you all the possibilities to throw in a certain direction. So this one, it rotates this way on the bottom, and then also rotates that way. So that is going to be part of the mechanism. For the catapult, that's built in the mechanism. So technically, that I didn't think about that, but like technically, look at the line around the bottom where it turns. Let me see. Yeah, are you talking about this line right here? Yeah, I'm pretty sure it's pivoting like in the center. It's probably, well, maybe. Oh, well, I don't know. Maybe. Yeah, because this doesn't look attached to it, so it seems like it's free to rotate around this axis. So yeah, we could definitely. We're probably gonna use a system like that, but you actually brought up a idea that I didn't think about before, is that a pro to the catapult system is that we don't necessarily need a positioning system, because the positioning system is built within the shooting mechanism. So it's actually it's a pro in that way. I mean, to be honest, whatever. I mean, it's up to you. Whatever questions you have. I mean, the only thing that I see that we have a problem with so far is that, yeah, feel free. If you're gonna drop in on Monday, feel free to share whatever you find. I'm open ears. Like, I'm open minded. We'll go through this whole concept phase, and then hopefully at some point start designing, at least virtually, and then hopefully see more flaws and then refine the design, and then we'll finally get to build this thing, which should be a quick process. But yeah. But okay, before I wrap up the stream, I know I said I'll be here for an hour, already a little over an hour right now, but before we wrap up the stream, let me finish analyzing or rate the catapult, and then again, like, these ratings are not like set in stone. We could change these later as we think more and come up with new ideas, or whenever if you have research or something like that, we could definitely go through that. But yeah, let's go through this real quick. So a pro was mentioned before is that we don't necessarily need a catapult or a position system. So that is definitely a plus, because it simplifies the design. But it's still complicated, but it does simplify design. So do not need the position system, because it's like built in or integrated already. So it's more elegant of a design in terms of that respect, because it's one system less than the others. Hey man, yeah, no, if you can make any streams whenever you can, I really appreciate it. It means a lot to me. So yeah, I mean, you don't have to show up every time. It's up to you. So if you can make it, hey, I'll be here. Again, I'll be here on Mondays, Tuesdays, and Wednesdays. YouTube and Twitch. And if you can't catch the live stream, that's completely fine. The live streams are automatically uploaded to YouTube, and you can watch them there. So just letting you guys know. Okay, so since we have the catapult system, a 5.5, 4, and a 7. So, I mean, I don't think it's better than the tennis ball, or it's at least, The reason why I don't say it's better than the tennis ball shooter is because it's still more complicated than the tennis ball shooter. That's because of like the whole like controlling the ball location along the rail. If we're gonna use a rail system, that's still more difficult than just placing a ball in one location and then having it just sped up through like some spinning wheels. So it's less than the shooting mechanism. It's better than the fan shooter. Well, no, the fan shooter is like really, really simple until we look at the reloading aspect of it. I think we could reload the catapult a lot easier than the fan shooter. The spring-loaded shooter, we might have to come back to that because we could use a solenoid, and solenoids, in theory, are very simple to use. You just control the signal to the solenoid, and you're practically done. And then, if that were true, then it just has the same issue as the tennis ball shooters, just how to load the gun. So we're gonna leave this in question. So, is it really a 4 or maybe a little bit higher if we switch it to a solenoid? I think it's gonna be less than the spring shooter. So I guess we'll give it a 6. I mean, it's getting light outside for you. You've been up all night, I guess. Hey man, do your thing. I remember those sleepless nights I had back in the OG days, where I used to. I mean, I kind of still do it, but I remember going to parties on the weekend and just staying up all day. Oh god, those are the days, the partying days, at least for me. Anyway, going back to the catapult system. I'm gonna say give it a 6, maybe a 6. I think it's a solid 6. I mean, if you have any input, let me know. But I think I'm gonna give it a 6 because it's in between. It's better than the fan shooter, but not as good as the shooting mechanism. Or I mean, the tennis ball shooter, and not the spring-loaded shooter, which is probably gonna be a solenoid. So I'm gonna say that for now. Okay. So yeah, I'll give this a 6. Oh, it's not a good 6. Oh, you don't sleep much. I actually have problems sleeping too sometimes. Like yesterday, I couldn't sleep either. I don't know what it was, but I just couldn't sleep. It's just one of those nights. Like you feel tired, and then once you lay in bed, you're just not tired. I'm like, okay, well, I guess I'm not tired now. So, but to be honest, sleep is really a waste of time. Like, if you think about it, you spend like 8 hours a day sleeping, or most people, I should say. Most people spend 8 hours a day sleeping, and that's a third of their life spent like sleeping. And it's just like, wow, that's a lot of time wasted. But yeah, it's kind of more of like a depressing thought than anything. But anyway, that's just a thought. To be honest, there could be as many as there is. Like, there might be one for each link, or there might be just one motor, and then it's linked through like mechanical bars or something like that. I don't know. I don't know too much about robotics. Yeah, I'm lucky. Yeah, you are lucky, to be honest. 6 hours of sleep, that's crazy, man. I could barely like stay up with like 8 hours sometimes. Sometimes I sleep too much and I'm still tired. Like, I don't know. I'm weird. But yeah, man. Okay, I think I'm gonna end the stream now. Thank you for coming out, Dane. I really appreciate it. I hope to see you on the next stream. If you do research, you don't have to. Again, it's up to you. If you do research, let me know if you find anything. I'll be definitely interested to hear something. So I think we're gonna end that today. I'm gonna make sure I save this. Yeah, this thing's becoming way more cluttered than I thought. But we'll come back. Oh, before we go, I'm gonna say solenoid. All right, man. I'll see you Monday. Again, I'm gonna stream Monday, Tuesday, Wednesday, 6:30 to 8:30 PDT or Los Angeles time. So I'll see you then. All right, see you, Dane. I'm gonna put this. I'm gonna put solenoid so we could look at that next time. Okay. Okay, I'll see you guys later. If you can't catch the stream, or if you're gonna watch the stream, it's on my channel. It's archived on my YouTube channel. So I'll see you guys.